Now we're back to 2.1, lecture part 2, I guess. And we're going to start talking about what is on page 183, which is your distance formula. And the main thing to know about distance is simply that you can never have a negative distance. So your distance will always be positive. So think about that. You can't ever have a negative distance. You can't drive from here to Chicago and have a positive distance and then drive from Chicago to Peoria and then in return have a negative distance, right? Because you're still going a positive amount of miles, the same amount of miles roughly, depending on the route you took, of course. But in all, you'll never have a negative distance. So stating that distance is never negative, like we've already talked about, is the absolute value. We'll also take with lowercase d being the distance, you're going to take the absolute value of your distance, and that's just going to guarantee that no matter how you add or subtract your 2 points, you'll still have a positive outcome. So your distance between 2 points, let's say distance of P and Q. Let me graph that real quick. Here's your X, here's your Y, and you have some point, say P, and some point, say Q. And as you can tell here, I made them directly across from each other, so they have the same Y value, right? So here's your P, here's your Q. P would be some X value, but it would have the same Y value as your Q. Okay, so that means they're on a horizontal line directly across from each other. So your distance here would simply be I kind of goofed up. Here I should have said you have a x1, some x value, and some other x value. Let's say x1 and x2, but they're going to have the same y values. So I just left out the x part. Your generic formula for your distance will be x1 minus x2. And because you're taking the absolute value of this, you can actually say your same distance will be x2 minus x1. In the end, they'll be the same exact thing. So that's why we can state they're equal here. So now let's find the distance between these 2 points, P being 2, 1, and Q being negative 1 and 1. So we can see they both have the same y value. So because they have the same y value, we don't need to really even mess with the constant that's in the place of the y value. Again, distance of PQ is equal to the absolute value, what was it? x1 minus x2, or it could be x2 minus x1. So let's verify that. Let's say x1 is this point, or coming from P, and x2 is coming from Q. So if x1 is from P, then we have 2 minus the negative 1. And then we're going to have x2, which is negative 1, minus x1, which is 2. So we have a parentheses. We're going to do this side first now. We have the 2 minus the parentheses of negative 1. So we'll drop the parentheses, and 2 negatives will make it a positive. So it'll actually be 2 plus 1, which will be the absolute value of 3. And then over here on the right-hand side, you're going to have negative 1 minus 2, which will give you a negative 3. And each of these will end up equaling 3 because you're taking the absolute value of both. And 3 does equal 3. So therefore, you guys can see by this example that this here is an accurate statement, and it will always be that case because of your absolute values here and here. So, do another example. Let's have your P value, or your P point, be negative 1 and 2, and Q be negative 3 and 2. So again, our y values are the same, So our distance of PQ will simply be calculated by x1 minus x2, this being x1, this being x2. And you can, like you've already seen, x1 minus x2 is the same thing as x2 minus x1 as long as you have your absolute values in there. So it doesn't matter which x value from P or Q you assign to be x1 or x2. It'll still be the same outcome. So x1, let's say in this case, is negative 1 minus x2, which is negative 3. Again, we're going to drop the parentheses, and the negative 3 will become positive 3. So we're going to have negative 1 plus 3, which will be 2, and that's simply equal to 2. So this is your distance of P and Q. And if you were to think about this graphically, you could graph these 2 points. Say P, that's going to be at negative 1, 2, right there. And Q is negative 3, 2, which is right here. So this distance of 2 right here is actually the difference right here. So you have 1, 2, right? You have 2 points in between negative 1 and negative 3. So that's your overall distance there between these 2 points. Okay. Now what happens if we're graphing 2 points that look something like this? We have a point in quadrant 2 and a point in quadrant 3. Obviously these do not have the same y value nor the same x value. So in this case, your distance formula, let's say this is Q, this is P, point Q. The distance formula for something like this will be the square root of x2 minus x1 squared plus y2 minus y1, and again that will be squared. So this is, you'll use this formula here when you're trying to calculate the distance between 2 points when they are not directly across from each other on the y-axis. Okay, now I'll do a quick example. Okay, so we've got 2 points, P and Q again, and we've got 2, 2, so 1, 2, 1, 2. We've got a point right here, which is P. Then we have Q, which is negative 2, 1. So we want to calculate the distance between these 2 points right here. We want this distance. Now the formula, I'll rewrite it, was x2 minus x1 squared plus y2 minus y1 quantity squared. And all we have to do now is basically assign our x2 and our x1 to the different values up above for P and Q, right? And then likewise the y1 and the y2. Really it doesn't matter which point you pick to be your x1, y1 point or your y1, y2, x2 point, just as long as you keep the variables the same. So I vote, let's have this be x1, whoops, that's supposed to be y, my eraser. x1, y1, sorry about that, x2, y2. Now we can go ahead and plug our points in. So right here it says x2 minus x1. So we have x2 minus x1. So we have negative 2 minus 2, quantity squared. And again we've got y2 minus y1. So y2 minus y1, 1 minus 2, quantity squared. Now we've got, just to simplify, negative 2 minus 2, that'll give you a negative 4 squared. 1 minus 2, that'll leave you with a negative 1 squared. So negative 4 squared, that's going to be negative 4 times negative 4, so it's going to be positive, and it's going to be 16. And then negative 1 times negative 1, it's going to be a positive 1. So, and 1. Now you have 16 plus 1, 17. Square root of 17. So the distance here is equal to the square root of 17. Okay, sorry, I thought I had tapped the record button, but we're going to do another problem here real quick. We're going to have p of 3, negative 5, which is down here on the bottom of the graph. Then we're going to do q, which is negative 2, 8. So we're going to go 2 ticks to the left, and then 8 up for q. And again, let's just go ahead and do this as x1, y1, x2, y2. So we'll have general formula again. x2 minus x1 squared plus y2 minus y1 squared. This is going to be equal to, now we just plug in our values, x2, which is negative 2, minus x1, which is 3, quantity squared, plus y2, which is 8, minus y1, which is negative 5, quantity squared. All I have to do now is combine like terms, or what is inside the parentheses. Negative 2 minus 3 is going to give you a negative 5 squared. 8 minus a negative 5. You're going to drop the parentheses. The two negatives will make it positive. So then you have 8 plus 5, which will be 13. Quantity squared again. So the negative 5 squared, that's going to be 25. And 13 squared is going to be 169. Now, all we have to do now is just add these two together. So it's going to be 194. And the distance overall is the square root of 194. And that's how you calculate your distance.